Hello and welcome to the Crime Pays but Badly Doesn't. I don't know. Why do I do that? Why do I always got to fuck around? Why do I always have to, do the intro with these goofy fucking voices? What does that say about me? Am I just covering the initial discomfort of talking to you, you fucks, you random strangers? Uh, all you want to do is just listen to a botany podcast. And here I am, just acting like a clown. Jack, get off the couch. You know that. I got to sell this couch. I'm trying to liquidate. Anyway, he always does that. Why you got? I get these nice cushions for you. You got to sit on the couch. Don't look at me like that. It's fine. Anyway, I'm excited for today's podcast. I had a conversation with Nicola Berg, who's the curator of Asteraceae at the Camden Herbarium at Kirstenbosch Botanical Garden in South Africa. Now, if you don't know much about South Africa and don't care to know and will probably never be there, this will still be an interesting conversation because we talk about some perspectives on some of the plants down there and some of the weird-ass evolutionary things that they've done. In the daisy family, in the Asteraceae, the camps, the composites. I was blown away by some of the plants we saw down there in this family, so I reached out to her, and she was very kind and very willing to talk to my goofy ass about what's going on down there with the sunflower family, because there's some very weird stuff. We talk about the paper daisy clade, the Nephalioids with a G, Gnaph, and whatever. You can look the rest up. We talk about the calendulae. Of course, people know calendula for its use in herbal medicine. I know it because of its prominence as a very obnoxious weed in the gardens I started near my house on Mandela. Someone apparently threw a seed bomb. It's really that whole seed bomb thing is like, if you're going to do seed bombs, it's just kind of like a catchy thing. It sounds good, but if you're going to do seed bombs, at least use native plants. There's so many cool California natives or natives to your region if you're going to do that. I prefer, of course, just going out there with a fucking shovel and throwing stuff in the ground, but if you're going to just do, quote, seed bombs on bare soil, at least use natives. But anyway, and the genus Calendula is mostly Mediterranean, of course, but the tribe that it comes from, the Calendulae, Calenduleae, originated in South Africa. And it's thought the whole subfamily Asteroideae did as well. So, Jack, you can get back on the couch. I don't care. It's fine. I'm going to have to vacuum the thing anyway. Come on, come here. Dog's looking at me like You do that. That's psychological manipulation. You're guilting me. Get back up here. It's okay, man. Come on. Got to go get you a bully stick. So Calendulae, originated in South Africa and is super species rich there. Well, actually, it's not. I guess it's only 120 species, but they're very ubiquitous plants, and they're pretty. They were all over. Osteosperma being one of the most prominent ones I saw. Just again, these things are just covered in glands and trichomes, whatever. So, anyway, so we talked for maybe an hour and 20 minutes. Got a little messed up because we were originally scheduled to talk at 9 a.m. California time, which is 6 p.m. in South Africa. But, the U.S. does that whole daylight savings thing. So I was an hour behind. I woke up at 8, which is rather late for me. And it was actually, 9 because the clocks had been knocked by. Whatever, it's a fucking pain in the ass. But anyway, so this is a great conversation. But before we get into that, I'll do just to give you a little rundown what's been going on lately. Because I've just been super overwhelmed, and I haven't done like a proper intro in a while. So I got back from South Africa like September 30th, and then all of October I was here for a few days. Then I had to immediately leave again. All of October was spent just driving, just feeling like I was driving. I was living the American nightmare, just perpetually stuck in my car. Just hunched over in a can on wheels. And I drove south to Southern California, then east through Arizona, Nevada, drove to South Texas. I had to do some family stuff down there. Um, and then flew to Chicago from South Texas, and then had to drive once I was in Chicago. Saw my ma for a while, then had to drive from Chicago up to the Upper Peninsula of Michigan, through the great state of Wisconsin. Me and Al Scorch drove up to the Upper Peninsula of Michigan to speak at a little film festival and give a presentation. And then I drove back south, dropped Al off in Chicago, continued on, met up with my friend Mike Brody in Memphis. He's a photographer, just totally whimsically, just didn't even plan for this. He just called me the night before and said, I'm going to be in Memphis and, I'm heading south. So I said, I'll pick you up. And then we just, drove to South Texas. And I finally dropped them off in Phoenix. We drove to South Texas, then back up, stopped in West Texas to see some people. I've just been on the fucking road, man. And we were eating garbage too. Oh, I'm ashamed to tell you what I was eating. I don't really eat meat too much, so it was a little easier on my colon. But, just garbage. It was just garbage. Just, you hate yourself afterwards. But you comedically hate yourself. You kind of laugh at it a little bit, calling yourself a pig and chuckling. But, yeah, so now I'm back. And this whole time I was like barely getting any time to exercise at all or anything. So now I've been back to actually like being able to jump rope. 10 minutes of jump rope a day. It's not that much. 2 sets of 5 minutes. Break it up with like 50 squats and 30 push-ups. Just the minimal amount that I can do to make sure I sweat and get my heart rate up a little bit. Got to exercise your cardiovascular system. It's the main reason I'm doing it. The squats really fucking help, Just, really help your circulatory system. So anyway, so now I'm back in California and just kind of getting stuff together, getting ready to finally depart, which feels weird. The whole process of moving is itself like a session of psychedelic therapy. I've had a couple friends come and visit me, stay with me for 2 days, hold my hand while I lay there figuratively blindfolded, excising my past, going through the last 15 years of shit I've accumulated in this house. But, it's going to be good to leave California, but it's also very weird at the same time. But it's just, when I first moved there, I thought, especially to the neighborhood I live in now, I thought I'll never leave. I love it, Lots of brick, somewhat working class. Wasn't too fancy, wasn't too hip. Near the train yard and the port, it was close to my job. And now it's just, it's changing to something different. And I've talked so much shit and I've gone in such negative rants about it, complaining, like I tend to do, which I think is fine as long as you don't take yourself too seriously. You mix it up with some comedy. You could do that. You could be negative. Don't take yourself too seriously. Keep the geologic timescale, there in the background. Understand that we are but specks of dust on a long, drawn-out tape measure of time. But so I don't need to get too negative. But yeah, it's just changed, and I don't. There's things I'll always love about it, and there's some things that I don't love so much. And a lot of people I know are dipping out. I just I saw a Channel 5 news segment. Channel 5 is now apparently the name of that, what used to be All Gas No Brakes, that video show that was like a little segment. So I'm sure the guy would go out, this guy Andrew Callaghan would go out with a film crew and just film people. He'd put on like a cheap thrift store suit and just film America in all its dollar store glory. And just fucking, it's like everything those snooty Europeans think we are, he would film. And anyway, I guess he ran into some licensing errors, or he, signed a contract with some shitty media company that kind of screwed him over, and so he had to give away the all gas, no brake. Jack, stop look. No, you're fine. Stop looking at me like that. He just looks. No, get back on the couch. Come here. I want you to have the couch. Come over here. Come over here. What is it about neurotic cattle dogs, man? They're like, Jesus Christ. Come on, get up, get up, get up. It's like a Jew and an Italian, married together in union and produced a child. Like that persona. What the fuck am I talking about? Like that persona is the persona of Jack. of my little Queensland heel. You're fine. God damn it. All right. Just intense neuroses. But, and then when you take him outside for a walk, he's like barking and running around you, trying to round you up. So, this is a fucking rather long-winded rant. This feels good. I haven't done this in a while. But anyway, that Channel 5 news segment, they did something on like white reparations activists of Oakland, of course. And it was funny. It was a black dude interviewing them, and you should watch this segment that's on YouTube. And it's really, without being too negative, the people they filmed were the kind of people. First off, none of these people they filmed are from Oakland, and they're kind of just. And I'm not, I'm not even necessarily against reparations at all. This isn't about that. I think reparations in a lot of cases make sense, but these activists were really on one. It was like it was funny. So this guy's interviewing him, letting him say their bit, and at the end, this black dude just kind of, he's like, you can tell he's like, what the fuck? He puts his arm around one of them. He's like, well, your heart's in the right place. And then he just is like, damn, uhuru. So anyway, and I look at that demographic and I'm like, okay, that's kind of Oakland now. It's like to me at least, seems like the people, okay, the Caucasian demographic of white progressive that's got the BLM sign in the window, and you see them and you're like, that person's there, they got good values. And then you meet them and you just kind of, you realize, at least me personally, I have very little in common with them outside of the what's on the surface, these beliefs, maybe opinions about certain things, and they kind of suck to be around, They look good on paper. When you get to know them, you're kind of like, no, you're fucking annoying and I don't want to be around you. My friend Linda Neiman said, made a good point about that when I was interviewing her. She was a switchman, brakeman for Southern Pacific Railroad from the 70s through the late 90s. And she said, at some point I realized that just because I agreed with someone on something, or on certain beliefs or values did not mean that we were necessarily compatible, and in many cases we weren't. So, and that's kind of what's been happening, what I've been seeing around Oakland and the Bay lately. So it's just, and I think I've got my own opinions on it. I think maybe it's a class thing. Maybe maybe I could go out and say that like the wokies are, it's an inherently bourgeois white demographic, maybe. I don't know, whatever. But we're not here to talk about that, and I don't really care to. The point is, I don't feel, I feel like it's just time to move on from Oakland, despite the excellent climate and the excellent opportunities for horticulture in terms of stuff you can grow, and the wealth of botanical gardens and herbaria. I feel like it's still just time for me to maybe move on and explore a new landscape and habitat and set up somewhere else. I've just been here too long, and then there's all the psychological baggage that we all have with certain places. Maybe not all of us, maybe just my weird ass, but the psychological baggage that we have with houses and places that we've spent a large part of our life. The growing pains, if you will. So anyway, I don't know. The Upper Peninsula, when me and Al were out there, was fucking great. It's, Upper Peninsula, Michigan. Something I realized when I was up there was like the Midwest region and the Great Lakes in general they could be, como se dice, climate refuge. They could be a place where as the Southwest continues to dry out. That was something that blew me away when I came back from South Africa. I always love that initial culture shock when you're gone for a month out of the country and you come back, and just the shock of being in the United States again. You realize the fucking insanity at times that's here. Just the chaos, the intense population density, the fucking number of cars alone. I mean, it seems like there's like 5 cars for every person, and there's a shit ton of people on top of that. You really you just kind of wonder, what the fuck, man? Like, where is this going to go? Where's the end of, where is this trajectory going to take us, right? Because it doesn't seem so sustainable in some ways. Maybe it doesn't seem like doesn't seem the water alone. I mean, in a place where it gets 115 degrees, talking about southern Arizona during the summer, and you have such a such a high population density, such a heavy human footprint. How long is this really feasible? How many rivers are there that you can put your drinking straws in? How deep is the aquifer, and how long will that last? Um, so it makes me wonder. It makes me kind of like skeptically eye these places in the future that might be in store for them. And then I look at places like the Great Lakes region, and I'm like, this might be, as temperatures are slowly rising along a south to north gradient anyway, and then now you have this huge source of fresh water. At what point will this kind of be the ideal place to move to? The climate refuge. So anyway, but we were up in the Upper Peninsula of Michigan, which again has these frigid winters, but goddamn, it's really beautiful up there, and you have some really interesting geology, really old geology, really cool coniferous forests, really cool bags, those floating sphagnum bogs, sphagnum moss bogs. It's always pleasant going up there, but driving through Wisconsin can be kind of a drag sometimes. We saw like a giant fuck Biden pickup truck train in Peshtigo, Wisconsin, which why are they so? I just wanted to ask a few of them, why are you so mad? How has this personally affected you? And I don't care about Biden. I don't really care for him, but how has it affected you where you feel compelled to take your Sunday afternoon and dress your truck up in all these different flags and accoutrements and other bullshit and just drive around in circles, just trying to trigger the libs? It seems like a very juvenile thing to do. It seems very silly. It's like something like a 12-year-old would do. Um, and then you look at, I couldn't help but be somewhat judgmental of the people inside, and none of them looked very healthy. They looked, pale, worn down, mildly overweight. Probably a little bit more than mildly overweight. I just, I don't know. In a way, I kind of felt for him. I was like, Jesus Christ, man. The dupage. So, that's always the thing, too, coming back to the United States right now. The cultural situation we're in is fucking, it ain't pretty. Left or right, it's not pretty. It's a very, it's becoming more and more anti-intellectual, it seems to me. It's becoming more and more, let's all reduce our inherent cultural beliefs and values to memes and 148 character Twitter posts meant to engender likes and social media backpats, rather than, we're trying to arouse emotion rather than really solve any problems or put anything pragmatic out there. That's what I mean by anti-intellectual. So where's American culture going to go? I don't know. I don't know. I don't know if I want to be around to find out. We'll see. Something else. Let's see what else I wanted to talk about here. Oh, you might have seen the video that came out. Interviewed Buzz Blur, a notorious boxcar artist that I've been seeing for 30, 40 years. Well, I've been seeing him for 20 years, but he's been doing this for 30, 40 years. These little poems and drawings on freight trains. Got to interview him, speak with him. Really, really cool. Got me, just thinking about, what is art outside of because I feel like I've been making fun of art for so long because it's kind of taken on this pompous, upper class tone lately in America, and I think a lot of people feel that way. But here was a guy who was part of the working class who was just doing this stuff. Who was a switchman, a railroad switchman, who found it appropriate to express himself on the sides of boxcars and rail cars using little paint sticks, and it just got me thinking about how important that is for humans, I think, to just regurgitate their sense of reality out into the world in whatever way they can, and to, more importantly, to do it for yourself rather than when you're doing it, your intention for it being to just honestly reflect on the world rather than, put it up there for someone else to see or put it up there for someone else to be judged. Basically just doing it for yourself. Yeah, so it was cool to see small little town of Gurdon, Arkansas. And I liked Arkansas. I was impressed with Arkansas, to be honest. At least the stuff that we saw. I'm sure seems like a scary state to many people from other parts of the country, but scary state culturally. But I mean, Christ, we had a nice time. Little Rock seems pretty cool, and I'd like to spend more time there. So hopefully, this year when I'm actually in the country and not, I've got plans to maybe go back to South Africa. I got plans to maybe go other places in the Southern Hemisphere when they open up, but maybe I'll, hopefully be doing more videos on the Eastern North American flora. So anyway, all right, these fucking intros seem like they just go on too long. I can't believe I used to do these 50-minute introductions of just rants. And anyway, so let's cut straight to our conversation with Nikki Berg from the Compton Herbarium, Kirstenbosch Botanical Garden in South Africa. She's got a web page if you want to look her up with a lot of interesting stuff on there. Just look up Nicola Berg, Bergh, and type in Asteraceae, and you should get her web page. I'd give you the name of the web page, but it's some like obscure name, so it's kind of hard to. It's more practical to just do the Google. Use the Google. So anyway, well, let's just cut straight to it. Hope you enjoy it. I still got. If you want to order stickers, $15. Venmo Society is hell. I'll send you 8. I'm trying to get this fucking book put out. It's a book of drawings. Just got to do the. There's been some problems with the cover lettering, so hopefully I'll get that taken care of soon. I have to redraw it. It's one of like 9,000 things I got to do. I still got 100 gigabytes worth of video data that I have to edit and put together. And I'm, some of these videos, if I was going to do the whole day's worth of video, because I record it every day, I got a group by days. These would be hour-long videos, so I'm going to try to just break it up into 15-minute segments to make it easier on you, the viewer, and then just put out a barrage of them. And that's all I got going on right now. So appreciate your ongoing support. I give you my email, but I'm overwhelmed. When I look at my email inbox now, I just kind of want to lay down and curl up in a fetal position and stare at the wall. So anyway, that's all I got for you now. Hope you enjoy this conversation. Have a lovely rest of your day. Go fuck yourself. Bye. Hey everybody, welcome to the Crime Pays But Botany Doesn't podcast. I'm really excited for this, and I'm grateful that you took the time to talk to my silly ass. I'm here with Nicola Berg, who is the curator of Asteraceae at Kirstenbosch Botanical Garden at the Compton Herbarium, and also a botanist and phylogeneticist specializing in the composite family Asteraceae in South Africa, which is, that alone is like a huge, that's such a huge chunk of botanical information right there to take off. How do you cover that entire family? But she specializes in the paper daisies, tribe Nephaliae with the G, if that makes any sense, and calendulae. And of course, those are two groups that are exceptionally species rich in South Africa. And the paper daisies in the Southern Hemisphere, as you've probably heard me rant before, are fucking phenomenal. They're incredible. What they do is, in North America, we get Anopheles and Antennaria, which they're nice, but they're little small herbaceous things. Down in the Southern Hemisphere, in Australia and South Africa especially, we get the diversity is wild. These are woody shrubs with ericoid leaves, sclerophyllous foliage. Some of these have leaves that look like conifers. So anyway, getting right into it. Nikki, how you doing?
I'm good. Yeah, great.
Yeah, I appreciate you taking the time to talk to me. So let's just jump right into it. I guess the two groups that you study the most, the paper daisies and the calendulae. Should we talk about nephalioids first? Does that sound good? How did you get into those? And well, first off, talk about why you picked Asteraceae and what you do, and just kind of introduce yourself.
Sure. So actually, I started Prices, which was a study just on one species, the Rhinoceros, it's Elytra papus, and it was sort of a population level study doing population genetics. And I just traveled around the country getting all the populations of this plant. So I was just focusing on one thing. And then it just grew. I expanded out to look at all its relatives, and then realized that I'm probably in the best place in the world to study daisies, or comps you call them. We call them daisies. There's just such an amazing radiation. You know, I think the family probably started off in South America, as far as we know.
Right.
And then from what I can tell, from what we know, it looks like there were multiple dispersals over to this part of the world. And they didn't all take and turn into huge diversification, but a few of them did. And one of them seeded the huge subfamily, the Asteroideae, which since it seems to have done a lot of its early diversification in southern Africa, and that seeded huge radiations in the rest of the world as well, like big North American radiations in the sunflowers and relatives.
So Asteroideae, that's the subfamily. So that Asteroideae, am I understanding this correctly, had its origins in the African continent?
It looks like it in southern Africa, maybe even in the Cape.
Wow.
Because the sister group to the Asteroideae is this tiny little genus called Corymbium. It's only got 10 species.
Oh my God! Yeah, I forgot that's. I didn't see it in bloom, but that was one. Yeah, but I saw. Yeah, someone pointed out the foliage to me. That's a weird fucker right there. One of the weirdest composites. I had a friend who's actually, I believe he works at Kirstenbosch. His name's Rupert, but he was sending me photos of Corymbium, you know, because it's blooming. We were there like a month before it bloomed, and I don't know. I mean, I saw it and I was just blown away. It's one of those plants. When you know the family and you see this thing that looks like a monocot, it looks like an iris. You know, it's got parallel venation. It's got that little tuft of indumentum of fuzz at the base of those leaves, and you're like, how is this thing a composite? What a weird thing for composites to evolve. You know, so that whole family. Yeah, the whole family is South African, right?
Yeah, the Corymbium's a great way to trick first-time students. You say, identify this, and then kind of blow people's minds with that thing that looks like a monocot.
And that's sister to Asteroideae?
Yeah, that seems to be sister to the whole subfamily Asteroideae, and then all the lineages that seem to branch off after that have a southern African base. So there's Senecione. They seem to have all their early divergences in southern Africa, perhaps even in the Cape, in the sort of winter rainfall regions. Mm-hmm. So Senecione, Anthemidae, Nephili, the Calendulae, the Asteriae. These are tribes, Anthemidae, they're diverse in all over the world now.
What is that? What tribe is that?
The Anthemidae.
Anthem?
Yeah. So Anthemis and what's the plant that's commonly used to treat malaria?
Parthenium. Is that it? That's like a new world.
My mind. They're a weird group. They're also different from each other. That you wouldn't think they belong in the same tribe, but
Anthemium.
You're gonna have to edit this, Jay, while I get my brain together. The Anthemidae are things like Artemisia. That's the genus I'm thinking of.
Oh.
Artemisia afra. They used a lot to treat malaria here. And we've got genera that I don't know if you would have heard of. Eriocephalus, you mentioned in one of your podcasts, and Yersinia.
Yersinia, yeah. Is Yersinia in that subfamily?
It's in that tribe, actually. And it looks nothing like the other members of the tribe. Things like Athanasia and Marasmodes and Pensia in southern Africa.
Yersinias typically have those nodding heads before they flower. Is that correct?
Yeah, but there's a few things that do that. I think some of the Arcturidae do that too. Or when they develop fruits as well, they often nod. Yeah, it's the phylaries, the involucrobracts that we use to tell them apart.
Okay, yeah. So yeah, all right. I'm looking at Tribe Anthemidae. That's AN. For anyone listening who wants to look it up, it's ANTHEMIDEAE. And so that's Asteroideae, of course, and we were talking about the subfamily Asteroideae having its origins in South Africa. But we were talking about Yersinia specifically, and Yersinia, you're saying, is in Tribe Anthemidae as well.
Yeah, that's right.
Yeah, we saw quite a few of those. I always, when I'm looking at composites, and I tell everyone this too, look at the phylaries. It's the big indicator for a lot of these. Asteroideae, I have to admit, that's one subfamily that I look at and I'm like, just because it's so expansive and there's so much stuff in it. So I kind of, when I'm looking at taxonomies,
I agree.
But I need to not do that because apparently it's it's very important. So I need to go. I always just kind of go to the next taxon level below and look at tribe. What tribe is it in? But Asteroideae, that's pretty interesting. I did not know that it's presumed to have had its origins in South Africa. But I guess the origins of the composites, the sunflowers, the daisies. Is what? It's like Eocene, right? It's presumed to be around Eocene, maybe a little bit earlier.
Yeah, there's been a few studies around that. I mean, there was one where there's so few fossils. And there's been a fossil capitulum discovered some years back in South America, and then a lot of the rest of the dating comes from pollen grains. Which are pretty unsatisfying. There was a pollen grain presumed to belong to Asteraceae or a relative from Antarctica, and that was used in a dating exercise, and that put the family back, with the dinosaurs actually.
Yeah. Oh, Cretaceous. Yeah. Wow.
But it's probably a bit younger. Would be my guess. I think some of the age estimates put the whole family as 40 million years, and that seems really short for this enormous diversity to have evolved. So I wouldn't be surprised if it's older than that. It's
probably it's got to be, But anyway, I'd like to remind everybody too, Antarctica at that time, right around the time that comet slammed into the Yucatan, was a much different climate. It was very amenable to life. It wasn't a frigid rock. It was a massive green continent, and also the Atlantic Ocean between South America and South Africa was nowhere near as long. Maybe half the distance. I don't know. I'd have to look at like a tectonic chronology map, but of course, South America split off from Africa, and it's still moving away. So you get that spreading center in the middle of the Atlantic Ocean that runs north to south. So the distance between those two continents was not as large as it is today, 50 million years ago. So it would have been a dispersal would have been a little bit easier, say on the plumage of a bird or whatever. But anyway, but
maybe.
Yeah. What do you know about that? I mean, what are
big distances? I think it's still pretty big distances. I mean, it's probably the continents were probably fairly well established. I think in their present distances by the time the Asteraceae started dispersing out of South America. I don't know if there were other islands or land bridges they could jump across.
Right.
But it looks like they dispersed to southern Africa like 5 or 6 different times, based on what's left in the phylogenetic record now. All the different lineages.
And is there a presumed age? If you're doing molecular clocks on any of those dispersals, is there a presumed age on when it might have occurred, or when the first one might have occurred?
Well, I think probably our earliest diverging, if you can put it that way, daisy is something in the Metizi, like Gerbera and Pedicium in southern Africa, and I think a lot of those are kind of tropical groups. I don't have a date for you. We could look that up. We could check that up. To depending on the different dating analyses.
I'm looking at Tyronia
Yes, that would be.
Tyronia was another cool group. Tyronia from Hinterhuberni.
Oh, Tyronia.
Yeah, that was a cool
Did you
genus of
say?
shrubs. Yeah. But
Oh, that's a great genus.
we didn't see any Gerberas in bloom, unfortunately. I know that's one of the only mutisioids that you get down in South Africa, correct?
And you would have had to be in more subtropical climates. They're in the eastern summer rainfall part of the country.
Oh, okay. So there's not that many in the Cape then.
No, I don't think there's any in the Cape. We've got this, I think one of the keys to the diversity here as well is this climate variation, our habitat variation. And the western part of the country, or large parts of the country, have this essentially temperate climate with cool growing seasons, really. So,
Right.
Namaqualand, sort of winter rainfall desert, and then the Fynbos with winter rainfall, and the Cape Mountains, and then the Great Escarpment, which is a lot of it in the summer rainfall areas, but because it's high, it's quite cool.
Right. Yeah.
And it seems like a lot of the variation, and the daisies are no exceptional, it seems like a lot of the variation has evolved in those temperate climates.
Yeah, that's incredible, man. The
Yeah.
the
And it's interesting
mutisioids.
because daisies are generally more subtropical groups generally, although there have been huge temperate radiations
Yeah,
in the family.
the mutisioids. That was when I was in South America. That was probably one of my favorite plants to see there. One of my favorite groups because they're just these super weird. I mean, them and the Barnardesioids. Those quote unquote early branching lineages. So yeah, I would have loved to see Mutisioideae there. But yeah, I think we saw like one Gerbera that Stuart Hall pointed out to me, but it wasn't in flower yet. But anyway, going back to what you study. So let's talk about the paper daisies. Like what about those got you amped? What kind of got you enthralled about picking that group to study?
Well, when I started them, I actually had some people making comments like, "Why would you study something so ugly?" But of course, when you look down at even these things that have these tiny little capitula with just a couple of little florets inside, when you look down a microscope, they're incredible, and there's a lot of variation. So I started out studying the Stevie clade, which has these often quite small leaves. It's a Fynbos and Renosterfeld group, and it seems to have this reduction to just a single floret, a tendency to reduce to just a single floret per capitulum.
Mm-hmm.
And then it's got the Nephalae filaries, involucral bracts, which are sort of overlapping, like the imbricate, like roof tiles, and they're pretty defensive, I think.
Yeah, that was the one we saw. We saw Stevie Ethiopica, and it looked like a little fuzzy golf ball. And it was so cool. And one of those plants I saw, and I was like, "What? It's like, what is this? Holy shit! This is so weird. Looks like a little golf ball on like a juniper twig. Maybe 2 or 3 feet tall."
Yeah, and this is actually the amazing thing because all this diversity, all these daisies, like biggest family of flowering plants, they've all got the capitulate inflorescence. They've all got capitula, and yet they do things like in the Stevie clade you reduce to 1 floret per capitulum, but then you group a whole lot of capitula together into a compound sort of synflorescence, and then you can start making all kinds of inflorescence structures.
Yeah.
So I think the Nephalae do that quite a bit.
Yeah, we've got a plant that's in its own subfamily, Hecastoclys, out here in the deserts of North America. Another super oddball that again has one flower per capitulum. So anyone listening, we're talking about, you look at like a sunflower head, that's a capitulum. You got like 300 tiny little individual flowers in there. We're talking about composites, Asteraceae, that only have one little floret per capitulum. It's got one floret, and then it's surrounded by all these filaries, these involucral bracts. But because it's only one flower per capitulum, they're all grouped together. And in the case of Stevie, this plant we're talking about, it looks like that little fuzzy golf ball. It's like a little cluster of capitula. So, and you're saying a lot of the paper daisies do that.
Yeah. They don't all reduce to just one floret, but it's sort of a Nephalae feature that the way the variation in the way the capitula are arranged to make these inflorescences. It's often quite diagnostic if you want to identify the different genera.
And how could people call this group ugly? I'm looking at some of the observations on iNaturalist that I've got. Phainocoma prolifera. That thing was one of the weirdest ones I've seen. It's incredible, huge, and large.
So some of them do have the groups I was talking about. They don't have showy phyllaries, but you're right. There's things like Phainocoma with these incredibly beautiful, really shiny phyllaries.
Right. No, I'm all over the place. I'm just looking at stuff. This is like a ping pong ball conversation on my part, kind of the way my brain works with intense attention deficit disorder. But I'm just anyway. But yeah, let's get back. We'll talk about Phainocoma later. But with Stevie, go on. What else were you noticing and getting excited about when you were first looking into this group?
Well, there's some quite interesting. The other thing daisies do, so they're stuck with these little florets, and daisies have only a single ovule in each flower. Mm-hmm. So, but they can then do things like some of the tiny little florets in that capitulum will. They will be male functional only, so they're just there to produce pollen, often the central ones, and then they'll use the style is actually then used as a pollen presenter. So so the sort of the female function is then co-opted to push the pollen out of that little fused anther tube and present it to the pollinator.
Right, secondarypollenpresentation.com. Just like, in lobelias and some of the other asterales. Remember, I think goodenias do that too. No, they've got an indusium. It's a little bit different. But yeah, so that you got the secondary pollen presentation and those style, but also the morphology of those style branches in some of these composites is a big indicator too of lineage affiliations, correct?
Yeah, absolutely. It's a great diagnostic character. It's not one that most people in the field want to have to use, of course, because you kind of need a microscope to see it.
Yeah.
Yeah.
There's a
few things in the Nephele, like annuals as well, that do some strange things with the capitulum, like female florets outside what seems to be the primary capitulum. Sort of this strange little genus called Ephloga that I worked on for a while. That seems to play around with male and female sexuality in the florets.
And so go into that. How does it? I'm looking it up right now. Let's see if I can. I don't believe I saw that one. Maybe I did, but oh wow, that's a weird one.
They're tiny and they're not very attractive or showy at all. Not the annuals anyway. But yeah, so we did a study on Ephloga, and we were quite interested in, of course, if you're an annual, you've got to produce fruits to survive. You can't just hang out in that place because the plant will die, and then your survival into the next generation is completely dependent on whether you produce fruits or not. So we were thinking you're going to have to invest much more in female function as an annual. Mm-hmm. And so we were looking at the way the capitulum is used to produce more male only or female only or bisexual florets. And, Ephloga seems to be playing that game exactly. It's something that I think really would be interesting to look at across the daisies.
Produce tons of seed and then just, get it done quick, die, and then your seed will just lay in that seed bank till the next season or until, rainfall comes again. So yeah, I guess explain that again. Ephloga is basically it's accentuating the female function of the flowers above the male. You only need a few male florets, and then what exactly is going on?
Yeah, it looks like in the annuals they are investing more in female function.
Right.
Because when you have a capitulum and you can alter the investment in male or female flowers in your capitulum, it looks like the annuals do just that. invest more in the female function, and so produce more fruit and bigger fruit.
Oh, okay. So it's not like they've got necessarily more female florets. They're just I guess yeah. How do they do this?
Yeah, they'll produce more female and bisexual florets.
Mm-hmm.
And this is in these tiny capitula. The florets are they're like less than a millimeter wide, the little corolla tubes.
Jesus.
And the whole capitulum is just a few millimeters across.
So, yeah, so how do you study
and these tiny
things?
little things.
You need a microscope then, basically. I mean, that's something I've noticed
you need
about
a microscope.
a lot of these paper daisies too. I mean, some of even in relatively large capitula, some of the florets I look at are just fucking tiny, man. They're like, I break out the hand lens and that's not even enough.
Yeah, you need a good hand lens. Yeah, and actually, I'm pretty impressed with a lot of the cameras these days. You can take the most incredible pictures. So if you in the field pull open a capitulum and take some close-up pictures, you'll often, when you get home, see a lot more than you did. Looking with the naked eye.
Yeah, that was one of my main reasons for getting I invested in a macro lens. It was a few $100, for the Nikon that I use, and it was the main reason I was doing it was not because I want to be able to take pretty pictures, but because I want to get higher resolution, more up close images of these characters that I'm observing in the field, so that I could take them home and share them with others or use them as reference photos. And it was, once I decided to stop being such a cheapskate, I realized it was one of the better investments I've made because, investing in a macro lens, learning how to use it, learning how to get the depth of field, straight by using a small aperture and a flash, helped me learn more by being able to look at some of these character traits in plants I was studying. So like I'm looking at, what plant is this? Metallacea. I just lost it now. It was a Metallacea. Let's go down. I just lost the damn. There we go. Metallacea pallida. Yeah.
Oh, yes.
Yeah, and I've got this. I mean, it takes up the whole screen. It's like a 12 megabyte image of 5 capitula, and those capitula are only probably, Christ, I don't know, 4 millimeters wide at most. I mean, you can really get up there and look at them. That's do you mind if we talk about that genus for a minute? Have you studied that genus very much? Or do you know much about it?
No, I have to. I identify them for the Hebrew when people bring in IDs, and I know metallasias. They're pretty common, and there was actually a great treatment of them done by a Swedish botanist, which we use a lot. It's such a difficult genus. The characters to tell the species apart are so tiny, but they all seem to have these. they all seem to have just like 3 to 5 of these little purple florets per capitulum, and then these strange apically flattened pappus bristles. I don't know if you saw that if you used your macro lens and pulled them apart.
Yeah, I'm looking at one right now, and this is it's a pretty ubiquitous genus in the Western Cape. I mean, these things were everywhere, I mean, I'd be taking pictures of other plants and looking at the background, and I'm like, there's a Metallacea, but you're right, they are hard,
Yeah.
They're hard. I mean, I would get them down to genus and not bother with going to species, trying to key out species because I just didn't have time. But so these pappus bristles, I'm looking at these little hairs. You're saying that they're kind of truncate at the top, or what?
Yeah, they're just flattened. They're often very, very white, like opaque white in Metallacea, and then they just sort of widen out and are flattened at the tip. That seems to be a real Metallacea characteristic.
Mm-hmm. God damn, what a cool. And multi-seriate phyllaries and ericoid leaves that kind of end in a little spinose tip, and then they've got that indumentum on the abaxial surface, which is pretty typical of a lot of the plants there. That was something I noticed in the Feinbos that was so cool, is all these different unrelated lineages of families had these same adaptations to that climate. I mean, it was
absolutely.
Just the ericoid leaves, I guess explain what ericoid leaves are to anyone listening. Like what with these traits, like narrow leaves, kind of feeling like plastic up top with with
Sclerophyllus, we call it. Apparently it's a function of living in an environment where carbon is easy to produce, but the other nutrients are really not that available because of these really nutrient poor soils.
Oh, so
they're hard leaves, and it's very small, narrow, and often with rolled margins.
mm-hmm. So that's something that's pretty remarkable. That I was just assuming it was an adaptation to dry summers. I didn't realize it was also a result of nutrient poor soils of that quartzitic sandstone.
I think there's a link. Yeah.
Right.
And it's actually interesting. You were talking about Metalasia and a couple of the other Nephalae. So they actually have that white indentation on the adaxial surface of the leaf, but then they twist the leaf so that it ends up underneath.
Oh my God! Yeah, you're right. You're right. I'm looking at that. What the fuck? Oh my God! That's so cool. Yeah, I didn't even notice that before. I'm like, see, this is the important. Again, the investment in the Nikon 105 millimeter lens pays off, because I'm looking at this now and I'm like, yeah, that is. It's the abaxial. What is the abaxial? Pointing away from the axis of the plant is green and somewhat glabrous, and then the indumentum, that velvet, is on the adaxial surface. Yeah, the upper side of the leaf, and then they kind of twist. Wow, that's wild.
And then the margins are kind of rolled over that adaxial surface to kind of make I guess it makes like a little cup to hold those hairs, and then the stomata are under the hairs.
Right, they're folded. Jesus. Oh, wow. See, this is the importance of talking to a taxonomist and a professional who studies, and a herbarium curator especially. So with your title, I mean, you're basically, people bring stuff in and you just really put it under the microscope, figuratively speaking, or sometimes literally, and just try to look at all these different character traits, highly observant, highly attentive, and just figure out what it is that you're looking at, and then compare that with collection, locality, etc. So.
Yeah, and I think you can ID things from a field guide and all, and you can probably get it pretty close. But if you want a really reliable species identification, you have to work with the specimens.
Right.
I think that's the key about working in a herbarium and doing IDs in a herbarium. You then, because even when you do an ID, I'm sure you do this. You do an ID on INAT. You then go and you shuffle through other identified pictures to see if you're in the right ballpark, and you compare it to the other pictures.
Yeah, and
it's the same in a herbarium. That curated collection that's been seen by people who've been working on the group and has an ID on it. That's so valuable to compare with when you really want to get your ID down to species level.
Yeah, absolutely. I mean, when I was in the Dominican Republic in February. I went there because it was one of the only places that was, one, letting our nasty American asses in, and two, one of the only places that was relatively loose with their COVID restrictions. Yeah, like Australia, I'm not going to be able to get in there for a while. Americans don't have the best reputation in the in the rest of the world, and I understand it. I'm not knocking it, but when I was in the Dominican Republic, which has an incredible flora, and especially with Asteraceae, I mean, they've got some really weird stuff, but there was so much stuff that I just had no idea about, and it wasn't, half the things I saw weren't even on iNaturalist yet. No one had observed them yet or identified them, and there wasn't a page. So I had to hit the herbarium on my last day there, and I just kept harassing. They were kind of like, you got to make an appointment. Nah, who's this gringo? And finally, a friend of mine who lives there contacted, and he does a bunch of work with conservation, contacted the head of the herbarium and got him to let me in. And this guy, I mean, I'm so grateful for him, man. I mean, we went through everything, after hours on like a Friday, and he helped me identify all this stuff. And that I realized, right then, like without an herbarium, none of this stuff would be ID'd. I mean, none of it. It was, when you've got the specimen right there in front of you, nothing compares to that, so. Yeah, that's something definitely for anyone listening. You got a chance to go to a herbarium and just putz around or look around or hang out and look at stuff, definitely take it. I've been to many great ones, and I'm grateful for the time. Next time I'm in South Africa, I gotta hit the one at Kirstenbosch. But anyway, that's the Compton Herbarium, right?
You must come visit.
Compton.
Yes, that's where I'm based. Yeah, you must come visit.
Yeah. So anyway, okay. Well, I want to talk about.
Actually, Joey, what I'd really like to see the photos on INAT being linked to specimens. I think that would be so valuable because, of course, that the things you see on the photograph are what's missing in a herbarium specimen.
You mean
So
linking photos? Explain what you mean.
So that when someone collects a specimen to press and accession into a herbarium, they put the accession number on the photograph in INAT.
Yeah.
So that you can then use it as a resource. So you've got the press specimen with all the things that you can see and measure and extract from that, and all the metadata. But then you've also got the photographs, and if they're on INAT, they're publicly available, so the individual herbaria don't have to curate and manage the photographs.
Yeah, absolutely.
I think that would be a great way forward.
That's something my friend Alan Rockefeller, he's a mycologist, but he actually recommended that to me. He's like, I always whenever I collect, I put the INAT number, because every INAT observation is associated with a number, and it's down there at the bottom of the observation. If you scroll to it, I always put that in the herbarium label. And so I started doing that. I mean, I don't collect that much. I've got a box of collections I have to accession. I've already mounted them and labeled them. But I always put the INAT number at the bottom, because that way people can look it up and get, more of they can see the collection data, where it was collected, date, everything, but they can also see, character photographs and then habitat, pictures of habitat too. So,
that's a great idea.
So,
yeah.
But anyway, so let's talk about paper daisies for a little bit, and then I want to move on to calendulae, because that was a weird group, and a stinky group too. I mean, I kind of like the smell of that, but it's one of those, calendulae is one of those groups, you you touch them and you're like, God, your hands come off covered in oil and exudate, and then they stink too. I mean, I like them, but so some of the other cool paper daisies I saw was, let's see, Seriphium. What's going on there, man? That thing doesn't even look like a flowering plant, really. It's got highly reduced leaves, kind of looks like some sort of weird conifer.
Yeah, and that's the genus that's done this. One of the genera that's, like Stevie, done this thing of reducing to one floret per capitulum, and but even in Seriphium, there's a lot more diversity than there would seem, than you'd think. So yeah, we're in the process of probably describing some new species in Seriphium. It's a great plant, and the variation's very, very subtle, but it's there, and there's ecological differences. But this is another thing about this group of daisies, is that they seem to be one of the few daisy lineages, Metalasia and Seriphium and a few of the others, that have diversified on these really nutrient-poor soils of the Cape. And I think it's very un-daisy-like to grow in that kind of environment. And so once they've kind of cracked that ecological code, that's when they seem to have really done a lot of diversifying.
And do you know what? Do you know what exactly it is that allowed them? Like, what mutation or adaptive? What evolved that allowed them to be able to colonize these nutrient-poor rocky soils?
No, I don't know. I mean, it's a really harsh environment that has excluded a lot of lineages, and the Cape has this kind of island-like diversity.
Yeah.
Because of that, but once lineages get in, they really just seem to go crazy, like Erica with 700 species or
right.
so.
Yeah, because once you've got that, now you've got a clean slate, and you can just take it over. And no competitors, and you just there's room. There's room for everybody. There's room for intense speciation.
Yeah, but from here, these Nephali seem to have colonized. I think there's several expansions that they've done up into the tropical African highlands. So there's some Seriphium species up there as well, Seriphium kilimanjaricum, and a couple of Seriphium species on the Mascarene Islands, which I think is quite cool.
And they all have this kind of shrubby habitat shrubby habit with reduced leaves, or what are they? Yeah, I guess what's a trademark?
Yeah, they do. Some of them get a bit taller, but they all look pretty similar.
And what's their main pollinator? Small flies, or what gets at them?
I don't know. There's been speculation that they're wind pollinated, but maybe, but we need some brave pollination people who are going to take on that project and find out.
Mm-hmm. And then there's, let's see, another Galeoma. You familiar with that one? That little tiny Oculus Cati. Yeah, we saw that near Middletown. That was up on the Great Escarpment, I believe. That's like on the edge of the Great Escarpment, which for anybody listening,
that's right.
Geologically, it's kind of like this bulge in the South African continent that's elevated, much more inland and kind of elevated above the Cape. What's the elevation there? Like 3,000 or 4,000 feet, maybe. How many meters is that? 1,200 meters, maybe. I don't know.
Yeah, something like that. Yeah, and it sort of roughly almost follows the coastline, but maybe 100 kilometers or more inland from the coastline. It's got that kind of shape. So it's this interior plateau of the subcontinent.
Right. Is Galeoma, is that a pretty species-rich genus, or I haven't looked at it?
No, there's only 2 species.
Oh, wow.
But it's probably nested within Helichrysum. I mean, Helichrysum is another huge radiation.
Yeah. These little cotton balls on the rocky soil, on the rocky ground. With again,
yeah, they're great.
Tiny flowers, man. Jesus Christ, these things have to be not even a millimeter. Some of these individual florets. So.
Yeah, these little grey woolly Nephalae. There's a few of them in a couple of different genera as well. Like Valeria phyton is another one. And Lasiopogon, they're tiny little fluffy annuals, and there's actually so few morphological characters.
Yeah.
And so they're quite difficult to figure out. Actually, Lasiopogon has got one species, Lasiopogon debilis, which is it's an annual and it's succulent. Mm-hmm. Very cool little thing. I put a picture up on iNet, and I think a few people have posted photos of it. Tiny little plant, like maybe an inch across.
And it's a paper daisy?
Succulent leaves.
It's a paper daisy?
It is.
God, so succulence has evolved in the phalloids too.
Yes, but not very often. That's really quite unusual. It's that lineage hasn't managed to do it the way some others have.
Right. Yeah. that's like the Senesioids are. The Senesioids are predominantly that's the main group of succulent composites in South Africa, correct?
Yeah, I think so. I mean, I think Tyronia, which is in the Asteriae, all Tyronias are shrubs, but some of them get pretty succulent leaves. Mm-hmm. But they're not succulent like in the way Senecio, some of the Senecios and Athonas are. With most of the plant is just
some of those are crazy, man. I mean, what Caputia scaposa? That was another one. Almost looked like a Dudleya, like our North American Dudleya, with kind of in the epidermal tissue kind of wrinkles, I guess you could say, and so it gives it this kind of silvery sheen. It's like a bluish plant. That thing is wild. I mean, some of these things really threw me off. Some of those succulent Senecios really threw me off. With the Curios too, when I saw them in habitat. I mean, if I didn't see a flower head, or an inflorescence, I would think they were something, like some sort of crassula or something really bizarre. But some
of them are really small, aren't they?
Yeah, minute. Yeah. And I know you don't study those, but I mean, do you know anything about them? I guess when they radiated, when they just anything about them, evolutionarily or ecologically in South Africa. Anything very notable?
Senesionia are a very difficult group because it looks as if they've got this history of hybridization, but no, I mean, I don't know them so well. I think I've got some colleagues who work on them, but I tend to gravitate towards the shrubs and things. So there's this great genus Euryopsis. You might have seen a few Euryopses, as well. And I mean, it can be hard telling the Senecioni genera apart, but Europe's has got this great character where the peduncles always come off in amongst the leaves at the apex of the stem.
Okay. Oh yeah. Here's one right here.
they take so many different forms, so many different leaf shapes and sizes. But if that always helps me to figure out, oh, this is actually a Euryopsis I'm looking at, not something else.
Yeah,
It's quite a nice character.
Yeah, that's a somewhat species rich genus too. We saw quite a few of them there. They've got those kind of synesioid filaries, kind of one series, uniseries. But yeah, I see what you're saying. The peduncles come off kind of right above the leaf axils, correct?
Yeah.
Yeah, that's a weird group too. Well, anyway, okay. So back to what you studied though. So let's talk about the calendulae. What's I guess Osteospermum that's probably one of the most predominant and ubiquitous genera in the Cape. What are some other ones?
Osteospermum is the biggest one. I mean, actually, there have been some taxonomic changes, so people might know the genus Tripterus, but that's been sunk into Osteospermum now. And I think a lot of the smelly ones that you're talking about probably were things that were in Tripterus before. And actually, I mean, I call it Tripterus, but actually I think it's meant to be Tripterus because it's got three-winged fruits.
Mm-hmm. Yeah, that was another thing about the fruits on those. The achenes or the Cypsela. I mean, that's a big giveaway for this genus too. Is I mean, they're like these winged fruits, but some of them are drupes too. It looks like a berry almost. I mean, what's going on there?
Yeah. There's a couple of species, or a few more actually that make very berry-like fruit that are dispersed by birds and other vertebrates. I mean, I've eaten them. It's like a tiny little bit of really sweet, tasty flesh, but you just don't get enough.
Oh my God! I didn't know they were edible.
The hard bone-like seed inside. Yeah. So that's they're black when they ripe, and you'll see the birds going for them. Actually, that's the one Osteospermum moniliferum, very widespread and variable. There's numerous subspecies and varieties, and it's a huge problem in Australia. It's one of their most noxious weeds, and apparently it gets spread by kangaroos and all kinds of things in Australia.
I
going
bet.
for those little berries.
But that's, you know what, evolutionarily, that's a wonderful adaptation, because if you produce a fruit that animals are going to be dispersing long distances, you're going to get around, and you're going to start to dominate a landscape, and especially the more widespread you are, the more you ensure your survival. So I can see why that seems like that would be a pain in the ass if it escaped to a continent where it wasn't native.
Absolutely.
But that, for me, that was just so weird, because I don't, especially in North America, we don't associate any Asteraceae with berry-like fruits. I mean, it's technically, would you call it a drupe, or what? How would you even describe that?
I think so. Yeah, I think you'd call it a drupe.
It's just one seed.
And even here, it's extremely rare. It's there's very few Asteraceae that do that.
How many?
But the thing with calendulae don't have a pappus. They just never make a pappus. And so, I mean, one of the ideas, because they just explore a huge range of different fruit forms, and that's one of the ideas, that, you don't make a pappus, so you have to find other ways to disperse your fruits. And so they've come up with, I mean, there's Osteospermums that have spiny fruits that will stick onto, I guess, animals' feet. Mm-hmm. And Osteospermum acanthospermum is a little annual, which makes these really spiny, uneven length spines that once they've hardened up, it'll be pretty painful to get that in your foot. Mm-hmm. And then there's others with the three wings, and then the genus Dimorphotheca, which the rays produce little nuts, really, so tiny sculptured little nutlets, and then the disc florets produce these flattened, two-winged fruits. They're like a thin, flattened leaf with the little embryo in the middle, and those are, I would guess, wind dispersed as well.
Yeah, Jesus. So what happened in that lineage? I mean, in the calendulae, was the pappus was just lost, or what? I mean, how does that?
Yeah, they just don't have a pappus. I mean, there's quite a lot of pappus variation. So calendulae, Nephali, maybe Senecio, Anthemidae, and Asteroe, these five very diverse tribes in southern Africa, and each other's closest relatives kind of at the base of subfamily Asteroideae. And they don't all, there's variation in the pappus. Some of them have a pappus of little scales. A lot of the Anthemidae, the pappus is reduced to just a few little, almost like little weak trichomes that aren't going to do anything in dispersal. So but I think Calendula is the only one where it doesn't seem to have a pappus or any kind of pappus analog.
God, it's so weird.
It's actually not so species rich. There's only about 120 calendulae. So really, actually, for a daisy tribe, it's tiny, really, really small.
And they're primarily African? Calendula is primarily African, or what?
Yes. There's the genus Calendula, which is in the Mediterranean and the Northern Hemisphere, so greater Mediterranean area. And there's a few species, I think, that have spread all over the world and are often used in horticulture. But that's, I think there's a lot of variation there, but I think there's somewhere around 10 to 12 species recognized in Calendula. And that must be a single dispersal out of southern Africa to probably via the Afro-temperate track up the tropical African mountain chain.
Yeah, and so, but with this tribe, what's going on with the chemistry? Because like I was saying, I mean, some of these things really stink, and you touch these things, they're covered in glands. I mean, I'd be touching them, fondling these flowers, for video or to get macro shots, and my hands would come off just, shiny, covered in exudate. What's going on, with the secondary chemistry of this tribe?
Yeah, I don't know too much about it. I mean, I know that that genus Calendula is used a lot in medicine, alternative medicine, as pharmaceuticals, and nice smelly things. But the southern African ones haven't been studied so much. I mean, there's some Dimorphothecus that are toxic to domestic animals, to stock, and there's a kind of poisoning that's known from when I think sheep and things eat them. And I know I've come across some studies of some Dimorphothecus that have an acid, some kind of an acid that apparently has a lot of commercial potential as an oil, the kind of oil that gets used, I think, in industrial chemicals and things. I came across some studies, but I mean, there's no one actively looking into it right now, as far as I know.
Yeah, that's wild. Yeah. I would be curious to see what comes out. You run that through like gas chromatography or something. Yeah, I just.
Actually, I mean, the other thing in Osteosperma, we were talking about those drupes. There's a few of them that seem to produce fruit with an elaiosome, which is it's targeted to ants. It's a syndrome, this dispersal syndrome called Myrmecochory, where the ants actually disperse the fruits, but it's not that they disperse them. It's not like you're aiming to get the fruits far. What they do is it's very directed to a safe site. So the ants that are part of this syndrome, and I think there's just a few species that do it, they're very attracted to some chemical component of the elaiosome, and I guess the food reward on the elaiosome as well. It's often quite lipid rich. And they very quickly drag it underground to their nest, which means the fruit isn't predated by rodents. And also is in a nice fire-protected, nutrient-rich site, ready for germination.
Right.
And there's a few osteospermums that seem to do this. You can actually see the elaiosome on the fruit, like Osteospermum junceum and corymbosum.
Junceum, you said? Juncum?
Yeah.
Yeah, that's.
Actually, I think corymbosum is probably more. Junceum might be doing the bird dispersal as well. But corymbosum's, I think, got a definite, what looks like an elaiosome at one end, sort of a whitish structure at one end of the cylindrical fruit.
Let's see if I can get the paper. Oh, there's something. Oh, yeah. Let's see. Yeah, that's a way to do it. Get the ants to stash it underground for you. And, no rodent's going to mess with an ant nest. And then presumably, just after, they'll just presumably, be stashed there and get it. So these seeds probably have a very long shelf life too, some of these.
Yeah, I'd imagine so.
Yeah. All right. So going back, let's see. Do you what are some of the other genera that you study in that tribe and tribe Calendulae that you've worked on, and some other things you found, I guess, that really are pretty exciting or novel.
Well, you put me on the spot here. I mean, calendulae is small, so that's really the lot of them. There's Osteospermum. Osteospermum used to be a whole lot of different genera, but it probably makes more sense to just have them all in Osteospermum. So there's a couple of species that used to be in this genus Gibaria, and they've got this. The fruits are tiny, but they've got these weird sort of boss-like structure. They sort of reform, kind of curved, and with a thickened outer layer. They're quite beautiful, actually. I don't know what the purpose is of that.
I'm looking at Dimorphotheca pinnata right now. That was an interesting one I saw. Rather showy flowers. Yeah, I didn't know that was I didn't know. I could see the glands right now on the stem. Yeah, I didn't know that was tribe Calendulae.
Yeah.
But
Yeah, I call that the crown of thorns. I don't know if you can get an image of that in fruit. So in pinnata, the Dimorphotheca pinnata, the discs are sterile. They just produce pollen. They don't produce fruit, the disc flowers. And so you get this row of fruits on the outside produced by the ray flowers, and they often stay on the infructescence for a while. And they're really spiny. So I think there might be a dispersal mechanism. They might stick onto things with those little spines.
Right. Yeah. Probably
as well.
Yeah. I would guess just small rodents or even maybe mammals or birds or what? Let's see. God, the glands on these are fucking nuts, man. That's crazy. I can't get over that. The gland.
Dimorphotheca. Are you getting good images of big glands?
Yeah, I'm just looking at I'm just looking at a photo of the because whenever I take pictures of composites, I always make sure to get pictures of the phyllaries too because it's a good diagnostic factor. And I've got this one of it. Yeah, this flower that's bent at 90 degrees, and just the fucking glands are. I mean, it's just it's covered in. It looks like those early 1990s marijuana magazines. That was the thing here, in the United States. You'd go to a record store and they'd have High Times, and it's kind of ridiculous. It's just pictures of cannabis. Who cares? But it was kind of like that, just covered in these trichomes topped by a little gland. But yeah, I guess that is the trademark of of a tribe. Are there any calendulae that aren't very glandular?
I think they're all a bit glandular.
Yeah,
they all have it. But actually, when you look closely at a lot of these daisies, a lot of the South African daisies, there's always a few trichomes. There's always a few glands.
Right. But these are oily, though. I mean, this tribe is nuts. I mean, the Osteospermums, too. I mean, again, touching these things, my hands would just come off, covered in this stuff. It's pretty funny.
And it's a very distinctive smell.
Yeah, totally. I mean, I kind of like it. It's not that bad, but I can see, how it would make you not want to gnaw on it, either if you were an insect or a mammal, So, all right. Well, moving on. Do you mind if we talk about Arctotidae, the Guarterias and stuff?
No, not at all.
Because that was
and it's actually there's tribe Arctotidae, and then there's within that there's Arctotidini, which is I think that's where you're heading towards with the Guarterias.
Yeah.
And then there's the spiny daisies. That's when you talk about people maybe not liking the smell, but Berkea, I don't know if you came across any Berkeas.
Yeah, quite a few.
Really, really spiny, and I think you really have to be pretty dedicated to collect those plants because you're always going to end up with spines in your skin.
Yeah, you're going to have to wear.
They're pretty nasty.
You're going to have to wear gloves or something. I was surprised. I thought that would be a thistle. I was surprised to find out that this is subfamily, the chicory subfamily, essentially. Which, I mean, because in North America we normally associate chicories with 5 teeth on the end of each ligule, and this whole tribe Arctotidii it does not really abide by that, and it was kind of a surprise when it came out in a molecular phylogeny that it was lumped in the chicory subfamily. Correct? I mean, what do you know about this tribe?
Yeah, I think actually there's a lot of quite strange things in there that we're not so sure about. I mean, there's this genus Heterolepis, which is kind of unplaced. Vicky Funk, I think you met Vicky Funk. She was very interested in Heterolepis as well. But no, we still don't really know where it's placed. There's some bizarre things like Platycarpa. And outside Arctodini, by the way, did you see Hoplophyllum when you were in Namaqualand? Talking about spiny things. Hoplophyllum, I think it's monotypical, maybe 2 species, and that's a bizarre daisy. It's kind of, I think it might have photosynthetic stems rather than leaves.
No,
and the
I don't
stems
think
are
I
very
saw
striate.
that. I don't think I saw that one. No. But it's
in the much more arid areas, and it's quite vicious with the spines. It'll grow like on the quartz patches with all the mesems, really arid desert-like parts of Namaqualand.
Haplophyllum. So how are we spelling this? Haplophyllum.
It's HOP. Yeah, did you get that?
Wait. HOP. How do you spell that?
Yes, Hoploph.
Oh, there we go.
Why?
Oh, Jesus. Oh, God. No, I don't think I saw this thing. God, what a weirdo. That's amazing. Oh, man.
Yeah, that's a weird one.
And this is an Arctotidii as well?
It's actually, but it's close within the Chicorioideae. Mm-hmm. Yeah.
Oh, yeah, that thing's, Jesus Christ, man. It looks like a crucifixion thorn.
I'm getting sidetracked.
Yeah, no, this is good, though. This is, I love getting sidetracked talking about interesting plants is worth it. Yeah, Hoplophyllum ferox and Hoplophyllum spinosum, tribe Eramothamniae of the chicory subfamily. Yeah, Jesus Christ. Yeah. That's a mean bastard, man. Does it have even like vestigial leaves? Does it produce small leaves at all, or no?
I'm trying to remember when I've seen it. I think it might actually, but you often don't see them depending on the time of year when you see the plants, and they're always in these really dry habitats.
Yeah, there's a couple like north of the Cedarburg, looking at those. Looks like around those quartz plains. Yeah, those. Where all those mesems are. But anyway, okay, so back, what were we talking about before? I got sidetracked too.
Oh yes, the Arctodini. So this is another thing with in the Arctodini, the big genus there is Arctotis, and it's one of those things people who aren't used to identifying daisies will always photograph the capitulum face on, right?
Right.
And you can't tell the difference often without looking at really tiny characters between an Arctotis, say, and an Osteospermum when the photograph is like that. So, as you said, the importance of taking a picture of those, from the capitulum from the side, so you get those phyllaries and things. And actually in Arctotis, the phyllaries are so interesting because the ones, the inner ones, which are closest to the florets, are very tightly pressed to the capitulum, and then they have this sort of translucent or transparent apex. And then the outer phyllaries have a completely different structure. They're often kind of leaf-like or hairy, and they might be long and linear.
Mm-hmm. Let's see, because some of these. God, the most remarkable thing that I noticed about this was some of the patterns on, if you are looking face on, some of the patterns on many of these flowers, like of course the quote unquote beetle daisies, which Again, that pattern,
Yes.
the pattern on the ligules is probably not actually a result of selection by beetles, but a selection of Megapalpus capensis, the Cape bee fly. But so much variation, like in Gorteria diffusa alone, that the one that basically, I mean, it's remarkable. This thing fucking mimics insects with its ligules, and one of the subspecies, there's quite a few different subspecies, right? One of the subspecies has.
Yeah,
Go ahead.
I think they are at the moment. Yeah, no, you go ahead. Carry on.
One of the subspecies I saw. I mean, it's got three specialized ligules that it produces that stand out from all the others. They're elevated above all the others. So three specialized rays, and these things are embossed. I mean, from 5 feet away, it looks like there's like three beetles on it. I mean, it was fucking mind blowing. It was the weirdest. Just totally, again, one of those reasons why that whole region is like a plant evolution classroom. I mean, just looking at what some of these things are doing. And then, of course, you got Pelargonium. There's a Pelargonium that does the same thing with the mimicry of insects, to attract them for pollination. But yeah, like the Gazanias and the Gorterias, a lot of those can look alike. And then you look at the phylaries, you see that Gazania's got glabrous phylaries, and they're a little bit more elongated and kind of, connate. They're fused at the, halfway
they're
up.
fused into a cup.
Right. Yeah, and then the Gorterias tend to have more spiny, thin phylaries with, covered in hairs and stuff. Is that about right?
Yeah, that's right. And those spots on the Gorterias, there seems to be so much variation in. I think there's even variation in how the spots are formed, because it seems that the flies are pretty easy to confuse, and so any kind of development of a vaguely fly-like structure, I think, gets you pollinated. Mm-hmm. I think that was the finding. So the different populations seem to have developed different ways of confusing the flies, and I think it's pseudocopulatory. I think that it's these naive male flies that come thinking there's a female fly. And I think they learn. Then they learn, there's nothing here for me. And as they get a bit older and more experienced, they probably become less effective pollinators.
Right. Yeah.
As a result.
But it works for a while when they're young. Yeah, I'm looking at this. Anyone who wants to, check out some of these Gorterias, you can go to INAT and just do an observation search for Gorteria. If you want to look at mine, type in Gorteria and then just put, filter it by user, Joey Santor. But I've seen, Gorteria integrifolia, seen two of those, Gorteria diffusa, quite a number of those. God, some of the Gorteria diffusas look so different. It's kind of hard to believe they're in the same species. I mean, I'm looking at one that's only got two beetle patterns on it. Another that's completely surrounded on the inside of the perianth by beetle patterns, and there's that one with the three prominent embossed beetle ligules. Yeah, I mean, so what's going on here? Why is there so much variation in what's considered the same species?
Yeah, I don't know. I mean, this, I guess the one answer is that maybe they aren't all the same species, and that you start needing to use genetic tools to look at that as well, because they're all vegetatively so similar. Mm-hmm. And so, but I mean, if the taxonomy was done from herbarium specimens where these features aren't preserved, then people aren't going to be able to observe all this variation. So fieldwork is really, really important, and then documenting it. And I've got a colleague at Stellenbosch called Alan Ellis who's working on this group, and I think he's exploring this variation, and he's actually working with me on the calendulae as well. And we're finding a complex in the calendulae, this annual Dimorphotheca complex, where they also seem to be. It's a different fly, but they seem to also be. You find this kind of remarkable variation, not in beetle spots, but in different. This sort of bullseye color patterns. There'll be like different colors of the rays, and then there might be a different darker ring at the base of the rays. Mm-hmm. And then the disc florets also often have this really shiny black the immature disc florets. So the outsides of the corolla lobes, when they're closed, can be very sculptured and very shiny, or different colors with hairs, and they often are also a bit longer than the other disc florets, so they make a very three-dimensional structure which pushes up in the middle of that disc. And this also seems to attract different species of flies and be involved in pollination.
And so
generating all this variation.
What if people want to look at this? What's the species name? And I guess first, what's the species name? And then
so that's Dimorphotheca sinuata.
Okay, all right. And have you guys published any papers on these yet, or is this just ongoing work, or what?
I think Alan might have published something. I must check with him actually, but most of it is ongoing work.
And this it's
Dimorphotheca sinuata and pluvialis.
And what's the insect that it is selecting for these traits?
It's a fly. What is the fly again? You can see this isn't quite my side of the whole thing. It's see little fluffy flies. What are they called?
Oh, here's a paper actually. Geographic.
I'll have to check it up for you.
Oh God, the site's under maintenance. Oh Christ! All right, geographic mosaics of fly pollinators with divergent color, and then it says, and I can't read. It's Frontiers in Ecology. It looks like, and then the papers. I'm getting like a 503 notice when I go to the website. Yeah, that's frustrating. Let's see. Here's another one. Let's see if this one comes up. There we go. Yeah, by Alan Ellis and Bruce Anderson and Jareen Kemp. Geographic mosaics of fly pollinators with divergent color preferences drive landscape scale structuring of flower color in daisy communities. That's a long title, but it's fucking interesting, and I'm going to have to read this paper later. God, that's cool.
And you'll get the name of the fly in there.
Yeah, that's another thing that South Africa did to me, was it made me realize, all right, I got to get into I need to get into insects, because there's the selection pressure. They're doing a lot of the selecting and a lot of the angiosperms down there. I mean, it's pretty mind blowing. And of course the poster child for that's Megapalpus capensis and like that Pelargonium tricolor or Guarteria diffusa, but it's nuts. Oh yeah, different bee fly pollinators dominated in both community types, so that largely non-overlapping pollinator distributions were strongly associated with different flower colors. Jesus Christ, that's cool. I was I use the analogy when I'm talking about evolution to people, or when I'm trying to get people excited about evolution or teach them. I always use the analogy of human selection pressure, like plant breeding or dog breeding, whatever, with what the environment does. Humans do it, selecting for traits that may not be adaptive in the environment, but are beneficial to us. We like them because they're showy or whatever. You comparing that with what the environment selects for over a much longer and drawn out time span. And I was with a friend last night who lives here, and he hybridizes and breeds mesums. Like, he's a big mesum guy, all the cool lithops and conophytums and titanopsis and all this stuff. And he'll just he'll go in, and he was showing me how he does it. He'll throw out so many plants. He breeds them, pollinates them with a paintbrush, collects the seed, grows a flat, picks out 5, and just throws the rest away. And it was funny because I was even asking him, like, can I have some of these? I'll pot them up and give them away to people. And he's like, no, I don't want them out there. I want them gone from the gene pool. Like this kind of like plant, Hitler. Like, I want them gone from the gene pool. Like, really, like it's kind of a morbid fucking analogy. Excuse me, but you know what I mean. And I was like,
but we do have to be careful, because like Dimorphotheca sinuata, there's several forms that are sold. You can buy packets of seeds from the Kirstenbosch flower shop, from any local nursery. Mm-hmm. And so when we're looking at variation in the field, every time you go near a town or even a farm, you really got to be careful, because these things are introgressing out into the natural populations.
Right, you're affecting. People are planting these things.
What's there naturally.
Right, people are planting these things and then affecting the natural variation that occurs by through environment. That's making it harder to study.
Exactly.
But it's just
Yeah.
yeah, it's just so cool to think that I mean in this case my friend is being the one that's selecting for different traits that he likes and then but in the environment out there in South Africa it's these a lot of the times it seems like it's these insects selecting for different traits and directing the evolutionary trajectory of many of these lineages. It's so cool. It's so goddamn cool.
Yeah. Yeah. And it's Corsomiza. That's the other fly genus.
Spell that again?
Corsomiza flies.
How,
It's CORSOMYZA.
uh-huh. OMYZA.
Yeah.
Corsomiza. Let's see.
Corsomiza, yeah.
Oh, that's a thing too. Yeah, there's just
Cute
yeah.
little furry guys.
Oh yeah, look at it. Look at that guy. Look at him. That's cool. Yeah, there's iNaturalist. That's the thing is like I've noticed with insects too. You'll type in some of these. A lot of people just aren't interested in insects. Not as many as plants. And so it's been hard for me to find pictures of some of these stuff. Thank God for iNaturalist. Thank God for the nerds out there logging and taking photos. But yeah, that's cool. Here's one on I can't tell what type of. Oh, it's on a It's on Isoaceae. But yeah, it looks like it's just a little fuzzy bee fly with I guess that would be a proboscis, that little black.
They've got pretty long proboscises. Probosci.
Yeah. So
Yeah, and I think they often do mate on the flowers.
yeah.
They seem to like flowers that have other flies on them.
Yeah, I saw that with beetles too. There's so many beetles in South Africa. That got me stoked on beetles. Again, insects I was kind of just turned a blind eye to for a long time, but we'd come up on flowers and there would be beetles just stuck in it, ass out, head inside the inner part of the flower, just kind of sitting there, it was really funny, just looking like they're drunk,
You
passed
must
out in
have
the
seen
flower.
those monkey beetles with the really long hind legs sticking out of the flower.
Yeah.
See those.
Right, yeah, and some of the ones, we'd find them in proteas a lot. Some of the larger beetles, I forget the name of them. I've got them logged on iNaturalist, but really, really fascinating stuff. But yeah, that tribe, the Arctoctidae, was probably one of my favorites to come across of composites. I mean, just man, that especially Gorteria personata. It's got like blue undersides to the ligules. That's a really weird trait. You rarely see blue in composites. Let's see. Anyway, well, I know you got to get going soon, but do you have time to talk about any of the thistle subfamily, really quick?
So are you talking about like Mutisia, or the cardioids?
Yeah.
Like Dicoma and Macledium.
Let's see. Let me see what.
They're not so diverse. They're very pretty actually. A lot of those.
Yeah. Oh, there we go. Macledium spinosum. Oh, and Tarchonanthus too. That's an odd one. Wow.
Oh yes.
Yeah. I guess that's all I saw.
So Tarchonanthus, and did you come across? You wouldn't have been in the area where Oldenburgia grows.
No, but I know that plant.
That's more in the Eastern Cape.
Right, yeah, I would love to see that. The grandis, I would love to see. It's like this tree-like thistle, super slow growing with very coriaceous leaves, like leathery, in some cases 10-inch long leaves. My friend, a friend of mine grows it here. My friend Martin Grantham, who's obsessed with the Cape flora, and he grows. He's got one or two of them in his front yard, but no, I was hoping to see, like Paradoxa, the small one, but I didn't really.
Oh, you have to climb for that.
You have to hike for that?
Yeah, you have to hike to see those.
Where does that grow? Where's Paradoxa occur?
So I've seen it I've seen it above a little town called Riversdale in the Western Cape. There's a mountain range there called the Langeberg. Which means the long mountains. It's a long mountain range, and just sort of on the summits there.
Yeah, there it is, just forming mats over the rocks. Jesus, that thing looks cool.
Yeah,
God
yeah.
damn. Just looking like a. Yeah, anyone who wants to look up photos, Oldenburgia, Oldenburgia, Paradoxa, and there's some pretty good photos online of this thing. Just, yeah, like leathery leaves, but, fuzzy on the underside, and just draped like a carpet over some of these rocks and these, just what looks like an incredible. Yeah, just an incredible habitat. What elevation is this, you think? Like 1,000 meters, 1,500 meters, a little bit less?
Yeah.
Yeah,
Maybe even a little bit lower. Maybe it goes like 800 to 1,500. Yeah.
God, I'd love to look at that flower up close. Christ, I can't. Yeah, this is the thing I always run into. It's hard to find macro shots of some of these plants, which is why I'm always trying to take photos and put them up for Creative Commons use so other people can reference them.
Yeah, that's great.
Well, so I guess okay. So I'll let you go. I won't. I won't keep you too much longer. But anything you want to talk about, like the work you're doing, anything that you're excited about, studying comps down there. Yeah, I guess what's going
There's so
on?
much to do, Joe. So little time. It's just fantastic. I think it's one of the best places in the world to study daisies because we've got such a range across the whole phylogeny of the family here.
Mm-hmm.
But I think I also hear of the places you've been and the daisies you've seen. I'm kind of jealous as well. I'd like to travel some more and see some in other parts of the world. But no, I think we need more people to study the daisies. We need more daisy specialists to explore. And I think a lot of people, apart from taxonomy, there's so many interesting evolutionary questions that are just ready for people to explore. Some of the things we've spoken about now.
Right.
So, there's still a lot.
Yeah, it's one of the it's I mean it's the most ecologically successful plant family, arguably. Like more so than Fabaceae. Even it's just by in the sheer number of species in Asteraceae, especially colonized every continent, but Antarctica. I mean the peas they got the rhizobium. I'll give them that. They've got that nitrogen fixing bacteria. They thrive in deserts, but the composites are, I mean, goddamn, they've really occupied every niche. That was what initially got me into them, man. I mean, I turned a blind eye to them for so long, and then I met a couple friends that turned me on to them that were studying them, and I just realized it's time to go deep and get into them. And so, and really, again, when I learned the thing about they don't all look the same once you start looking at the phylaries, at those involucral bracts, and looking at the undersides of flowers, etc. That's when I really went nuts